Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient, it'll just be the one that I come up with first as I'm working through the problem. So this one is number 101 on the site. Looks like we're going through the tree section because this is symmetric tree. So given the root of a binary tree, check whether it is a mirror of itself, i.e. symmetric around its center. So here they have example 1, where you can obviously see that this is symmetric. So specifically symmetric, because you have 2, 3, 4, and then you have 2, 4, 3, okay? And then this one's true, this one's false, because it's not symmetric. They're the same, but they need to be symmetric. Number of nodes is between 1 and 1,000, and each value can be negative 100 to 100, okay? And inclusive. So at first glance, this seems kind of similar to the last problem we did where we were just checking if two trees were the same. But there is the special caveat that they need to be symmetric specifically. So I think that we're going to be able to actually use basically similar code to how we checked the last one where we checked where they're the same tree. So if it wasn't specifically symmetric, right? If we were just checking if the left side of this and the right side of this were the same, then it's almost exactly the same problem as 100, where we were just checking if two different tree nodes were the same. All you would need to do is, instead of checking two completely separate trees, you just are essentially moving it so that now you're just checking if these two subnodes are the same. The only difference is that it's symmetric. I think we can use basically the same code and the same setup we did for the last problem. All we need to do is kind of rewire a couple things so that instead of making sure that, like, from this node the left node is the same as the left node on this one, you're just reversing it. You're making sure that the left node is the same as the right node from the other one. Like, it's just all the same thing but rewired to be reversed. So we'll go ahead and get started here. And actually, this is the tree node class. Let me copy over the solution here, as in the we'll go ahead and just add this tree node here. All right. So in here, you're given just the root of the tree node. So I'm going to separate this into two different tree nodes that are going to be the left and right children tree nodes. But we need to check that they have children. So first we have to do a quick little check just to say that if root.left is equal to null, or, and we have to, just to make this happy here, I'll just do if root is null, return false. I don't know if that's actually going to come up, but I don't want to have to force unwrap all of these. So if root.left is null, or root.right is null, return false. And now one of the questions, of course, that I'll just need to find out. So I'm not sure if they're ever going to give you, it says that there could be one node, so I'm sure they're going to give you an example of that. Technically, if it was just one node, it would probably be considered to be symmetric. So I'll just do a quick little if root.left equal to null and root.right is equal to null. Return true. So then I want to have a key. I'm just using P and Q to match what I had for the previous problem as far as what the variables were called, just to keep things easier. So P in this case is going to be equal to root.left, and val Q is going to be equal to root.right. Okay. And so here we're going to end up making a separate function. It's going to be called our symmetric nodes. Tree node 1 and tree node 2. So then in here, we're just going to return our symmetric nodes, and we're going to pass in P and Q. Well, at this point, we know that these are not going to be null, so we can force unwrap those because we did all the checking up here. So in our symmetric nodes, we're just going to do some easy checks here. So if the tree node dot val is not equal to the tree node 2 dot val, return false because we know they're not symmetric. Then we have to check for nulls. So if tree node 1 dot left is equal to null, and tree node 2, so this is going to be different from the last one, dot right is not equal to null. So now we're just checking for different structures. But this is just a slightly modified version because we're not checking the same sides. We want to check symmetrically. So from here, for example, if tree node dot left is null on this one, but this right one is null, then they would have a different structure symmetrically. Consequently, if tree node 1 dot left is not equal to null, and tree node 2 dot right is equal to null, return false. If tree node 1 dot right is equal to null, and tree node 2 dot left is not equal to null, return false. If tree node 1 dot right is not equal to null, and tree node 2 dot left is equal to null, return false. So now at this point, we are sure of the structure. If you get to this point in the code, the structures are at least the same. But we do need to check the values. So now we just say if tree node 1 dot left is not equal to null. We already know at this point, because of this previous checking, that that means that the right is also not null. Then we just say if not our symmetric nodes, tree node 1 dot left, and now we're going to do tree node 2 dot right. Return false. And then consequently down here, if tree node 1 dot right is not equal to null, if not our symmetric nodes, tree node 1 dot left or dot right, and tree node 2 dot left. Return false, and if it gets past all those checks, return true. So I'm going to go ahead and give this a shot. Run code. Okay, so that example worked. Let's do a submit. All right. Nice. It's always nice when you don't actually have any issues. So this one was pretty similar to the last one we did. We just had to slightly modify the way that we were doing it. Really interestingly, though, I believe that the last problem, number 100, we had low percentages with both the runtime and the memory usage. I think it was, in general, not that good of a solution. So it's really interesting that basically just a slight modification to the exact same thing we did last time for this problem ended up being faster than 92.18%. I mean, I'm really happy with that because this is technically one of the best answers. And it's also really good on memory usage. Not the best, but really good as well. Let's go over the code real quick. So here in our solution, we have our isSymmetric function, which just takes one tree node. We're going to go ahead and check here, do some guard clauses. So if it's null, we return false. And do some initial structure checking on the root node here. So if there's only one node, basically, is what we're checking here. If both of the children are null, then go ahead and return true because it's technically symmetric. And then if either of them are null, so in this case we know that they're not both null, but one of them is, then it must be false because they're obviously not symmetric. Then we just set p equal to root.left, q equal to root.right, which we know are not going to be null because of these checks, and we just run our symmetric nodes function, which is the more important function in this. So this takes two tree nodes. We first check if the values are not equal. If the values are not equal, return false. Then we check, is the left one null, but the right one not null on tree 2? Because remember, this is similar to our last one, but we're checking the opposite side since we're talking about symmetry and not equal trees. So is the left one null on the first tree and the right one not null? Then return false because the structure is wrong. If the left node is not null, but the right node on the second tree is null, same thing. And then we do the same check. I don't need to necessarily go over that on the other side. For these two, this is just structure checking. And now we're going to recursively end up going down and running this function again to check for the children nodes, because at this point we know the structures are the same. We need to check the values and further structure down the tree. So as long as the left node is not null, we know the right one's not null at this point, and then we just run this exact same function again on the left node for the first tree and the right node for the second tree, because once again, we're checking symmetry. Do the exact same thing on the right side, and then if none of these return false, then every single one of them ends up returning true all the way back up recursively to here, and we have our answer. All right, that's going to be it for this one. Hope that helped you guys out. Catch you guys next time. Thanks for watching.